Imagine being able to triple your potato harvest without synthetic fertilizer, without pesticides, without expensive garden tools, using a method that almost seems too simple, but unlocks enormous potential. And now picture this. That method was completely normal in 1905, passed down from generation to generation matter-of-factly, almost casually. Then it disappeared, quietly, without anyone noticing. Not because it stopped working, but because agriculture became more modern, and efficiency suddenly mattered more than understanding the soil. Today, millions of home gardeners reach for fertilizer from the garden center, hoping for quick results, while a simple technique from our great-grandparents' time has been almost completely forgotten. In this video, I'll show you why this method reportedly produced up to 3 times higher yields according to historical accounts, how it simultaneously improves soil fertility, why it was pushed out during the 20th century, and whether it still works today 120 years later. Stay until the end, because that's where I'll show you what happens when you combine this technique with modern soil science. The results are surprising, measurable, and for many people, completely unexpected. Around 1900, the potato was one of the most important staple foods in Europe, robust, nutritious, and reliable even in difficult times. In Germany, Britain, and the United States, small home gardens fed entire families, often on just a few square meters, but with remarkable productivity. Synthetic fertilizer was barely widespread. Industrial nitrogen fertilizer using the Haber-Bosch process wasn't produced on a large scale until after 1913, and later changed everything fundamentally. Farmers worked with manure, compost, crop rotation, and a particular technique for growing potatoes. This technique was described in gardening guides of the time, in agricultural handbooks that drew on 19th century field experience and documented practical observations. And here's the critical point. Instead of simply planting potatoes and hilling them up once, gardeners worked in stages alongside the plant's growth, attentively, patiently, almost in dialogue with the soil. Why does that matter so much? Because potatoes don't form their tubers just anywhere. They form along the underground stem, in a sensitive, light-protected zone. And that's exactly where this method focused: precise, thoughtful, and biologically sound. The technique is commonly called multi-stage hilling today, or historically, deep planting with progressive backfilling, a name that barely hints at its sophistication. Here's how it worked. The seed potatoes were placed deeper than usual into a prepared trench in loose, nutrient-rich soil. Once the plant had grown about 6 to 8 inches, soil was loosely mounded around the stems without injuring or smothering them. This process was repeated multiple times, each time new above-ground growth appeared, and the plant was strong enough. The goal: to artificially extend the underground portion of the stem and thereby maximize the plant's natural growth potential. Why? Potatoes form their tubers on stolons, underground lateral shoots that grow optimally only in darkness. The longer the protected stem zone, the more potential tuber sites, and the larger the possible harvest per plant. Historical accounts speak of significant yield increases, sometimes 2 to 3 times the harvest, compared to shallowly planted crops under identical conditions. Modern research confirms at least a clear effect. Studies on hilling technique show that proper earthing up promotes tuber formation, prevents greening from light exposure, and measurably increases yield per plant. But there's a critical difference between today's standard hilling and the historical method. And that difference makes everything. It's what separates an average harvest from an exceptional one. If this method was so effective, why has almost nobody used it since? Why does it barely appear in detail in modern gardening books? The answer lies in the 20th century. And it has to do with machines, time pressure, and chemistry, with a shift that changed agriculture forever. With the industrialization of agriculture, everything changed. Speed replaced patience. Scale replaced sensitivity. Tractors replaced manual labor. Fields grew larger. Efficiency per work hour became more important than efficiency per square meter. Multi-stage manual hilling was labor-intensive, especially across large plots with hundreds of plants. Machines worked better with standardized planting depths and uniform rows, not with individual care for each plant. At the same time, mineral fertilizers arrived. Nitrogen, phosphorus, and potassium could boost yields even without complex planting technique, seemingly simpler, faster, and more predictable. The problem? This development focused on short-term yield, not on long-term soil health or sustainable fertility. Soil compaction from heavy machinery, decline in organic matter, dependency on external inputs and global supply chains. Many small, soil-friendly techniques simply disappeared because they no longer fit the industrial system, even though they were biologically sound. But today, with rising fertilizer prices, climate conversations, and growing interest in self-sufficiency, it suddenly becomes interesting again. And here's the key question. Does the method still work in 2026, under modern conditions, in today's home gardens? Modern trials by organic gardeners and homesteaders show, yes, but with conditions that are often underestimated. What matters most: loose, humus-rich soil with good structure. No waterlogging that promotes rot. Enough spacing between plants for strong growth. And gradual, not excessive hilling at exactly the right moment. Why does it work? Because the plant gets more underground surface area for tuber formation and can better realize its genetic potential. At the same time, hilling protects against light and drying out, two main causes of green, bitter, or stunted tubers. An additional benefit that almost nobody mentions: repeated loosening of the soil aerates it, which visibly activates soil life. Earthworms, microorganisms, mycorrhizal fungi, all of these helpers thrive in loose, organic soil with stable growing conditions. That means not just more potatoes, but healthier soil for the next season and higher yields over the long term, year after year. But here's the important truth that many overlook. Not every variety responds the same way. Early varieties differently than late ones. Waxy varieties differently than flowery ones. And not every soil is suitable without preparation. Heavy clay soils need different groundwork than sandy locations. That's exactly what determines success or disappointment in the end. Before you head out this spring with full motivation to dig deep trenches and get started, there's a mistake that many people make, even though it's so easy to avoid. And this mistake can cut your harvest in half, even if you do everything else right. Too much hilling, too soon, from impatience or misplaced ambition. When young plants are covered too early and too completely, they're deprived of light. Photosynthesis stalls. Growth slows significantly. The plant invests its energy into survival instead of tuber formation. The historical method worked so well precisely because it followed the rhythm of plant growth, not a calendar date or fixed weekly schedule. Gardeners observed their plants daily. They acted when the plant was ready, not when the calendar said so. Observation instead of automatism, understanding instead of routine. That is the decisive difference between a mediocre and an exceptional harvest. The forgotten method of 1905 shows us something important. Higher yields don't always require more chemicals, more technology, or more expense. Sometimes all it takes is deeper understanding of the plant and respect for natural processes. This technique extends the productive stem zone. It promotes natural tuber formation. It improves soil structure. And it works without industrial inputs or expensive additions. It didn't disappear because it was bad. It disappeared because it didn't fit the industrial system. Maybe the future of gardening isn't in more technology, but in rediscovering intelligent, simple principles that proved themselves over decades. If you're growing potatoes this year, try it out with curiosity and a spirit of experimentation. Test one row the conventional way and one row using the 1905 method. Observe the difference yourself. Leaf growth, flowering, tuber size. Because sometimes the greatest innovation lies in a forgotten idea from yesterday.